And good morning and welcome back to the third part of our workshop tutorial here, how to build a 7S 8P battery, 24 volt. Well, talking about that, I wasn't quite clear in my first video of this tutorial that we have two batteries of these 12 volt AGM or GL lead acid batteries in series in my solar gate. I always showed only one battery, and then I talked about a 7S pack. But well, we have two of these batteries in series, so we've got a 24 volt system in the solar gate. All the motors in the solar gate are operated by 24 volts. Well, for me it was so obvious that I did not mention that. I have since changed the title of this video to make it clear. It is about a 24 volt battery, lead acid battery, which we are going to replace with all these beautiful lithium ion cells from used laptop batteries. Alright, and then in the last tutorial we manually balanced these packs basically. So these 8 parallel cells here, they all will be connected in parallel eventually, and we changed the capacities over to match them up as good as possible. So, and just as a reminder, we are only, hang on, what is the lowest one now? Yeah, 86 is the lowest and 95 is the highest. So we are 549 millivolt difference with all these battery cells now. Pretty good job for a manual packing, for a manual calibration of such a pack. And I told you there is another way you can do this. You don't have to do this manually. If you have hundreds of cells, this is probably not the way you want to do it. There is a website you can go to. It's a free website. It's called repacker.com. I'll link this down below as well. And this basically does this all for you. You have to put in all your battery capacities of each individual cell, and then the website, the script, and then the website calculates how to arrange these battery cells together to make the optimal battery pack for 24 volts, and in our case it's a 24 volt system. I definitely need to pay more attention to these details. What is very obvious for me is not obvious for you, of course. Okay, I'll do this on my mobile phone so you can actually exactly see what I'm doing on this website to get this all done. Okay, I'll step aside a little bit. I'll put the mobile phone here on the screen. So this is the website called rePackr. There's an E missing, right? repacker.com. So this is the website, repacker.com, with some news updates. And at the top here you can click on this little hammer symbol on the packer, and then you go into the pack builder straight away. This is now a 3-step process. So you need to provide a list of all the cells. Then you need to specify what you want to build, and then it generates the pack for you. So in the first step, of course, we need to enter all the battery capacities we have manually into this field and then separate them with a comma. This is a bit of a work, but I mean, we've done the same before as well when we put all these numbers into my calculator, you know, to calculate the capacity of each row. Okay, let me quickly do this for you, and then I'll be back here on the screen. Okay, I'm back. Well, this didn't take long, maybe probably 5 minutes or so. So this was 56 cell capacities I put into the app now. And now in the second step we click on the add cells. And now we have to specify, I've used this before, so there are some numbers already in there. We need to specify how many cells we have in series, which is 7. So we put in 7. And the capacity or the number of cells in parallel is 8. And the nominal voltage is 3.7 with these ones. That's not too important. And then we've got the option to choose between fixed and variable numbers. It's another word. So fixed numbers means it uses all these battery cells now to build this pack. Or if we use the variable number, and we can specify a milliamp hour capacity for each row, and it tries to match this capacity. So if we have a certain application, for example, which needs a certain minimum capacity of these battery cells. You can put this in there, and then it chooses the batteries accordingly to match or to achieve, to reach this capacity you need for your application. Okay, we stay with fixed at the moment because I want to use all the cells if possible, and then we just click on generate packs. Let's see, there are not enough cells provided to create this pack. I made a mistake apparently. Ah, God. Okay, back. I click on the back button. I have to check all the battery cells again. I probably made a mistake or something. Damn it! Would it do 7 in series, 8 capacity? Yeah, that should work. Okay, let me quickly check again. Come on, focus. Why is the camera so dark? Sun just came out. Okay, I found it. Third row, I missed a cell. So hopefully it works now. I click on add cells. And we are still on the 7 in series and 8 in parallel, 3.7 volts, fixed pack and generate packs. Okay, I clicked it. There it is. Here's our result. So it takes only 2 seconds to calculate this all together. That's amazing, right? What I will do is I will click on the compact button here on this one, so it gives us a better overview of what's going on. So here at the top we can see we've got 25.90002 volts, okay, 26 volts nominal voltage, and the average ampere hours of the whole pack is 13.59. What did we have here on the table? 13.59. Huh? Exactly what we had here on the table with our manual setup. Oh, now the camera is again, here we go. Which is 352 watt hours. So a quarter of a kilowatt hour we are getting with this pack. That's not too bad, right? So each of these gray blocks now gives you your battery pack, consists of 8 battery cells. You can see the 8 numbers with the capacities. So you can see the pack capacity of this one parallel pack. And then we've got 2 more information here. Divergence -1. That means that this pack is only 1 milliampere hour lower than the average pack capacity. And the deviation is within these 8 cells you see in the first block. There is a difference from the lowest cell we're using, probably the 1567 at the bottom, to the highest one, 1785. This is 70 milliampere hours difference. This does not create any problems or something. You can parallel lower capacity cells with higher capacity cells, but it gives you just an information how close this one pack now is. So each gray box here gives you the 8 battery cells you need to put together in parallel. And you can see the divergence is -1, -1, -1, 0, -1. That is a pretty good result. So this is better than my 9 milliampere hours I have done manually here. We've got only a difference of 1 milliampere hour in this battery pack calculated by the system here. And at the bottom you can see unused cells. So if you have more than 56 cells for such a project, and so it only will use the battery cells it needs to build the perfect pack basically. So you may have some spares if you put more battery cells in you have available. And I just have a quick look in the deviation of each battery pack, of each parallel pack. So this website did an amazing job to find the optimal configuration of our battery pack. Now it comes the difficult part to actually find these battery cells and put them together in one parallel pack. The good thing is they are ordered as per capacity. So it starts with the highest capacity and then goes lower as we go. And this is probably something you need to do with your batteries anyway. You need to sort them as per capacity, starting from the highest and then build them up in a row until the lowest one, so you can actually see the capacity. Well, yeah, and then you just go through this list here and pick the battery cells as you go. And once you pick them, you can actually click on them and mark them green, so you know you have picked this already. And so you can see after a while then you pick all these battery cells as you found them and put them in little groups of 8. So the problem I now have is my battery pack is wildly mixed now as per capacities. I didn't pay attention to sort them in an order because we did the manual configuration before. But this one here is a lot easier if you have them stacked up from the highest to the lowest capacity already. Yeah, I think so far this is what we can see on this website here. At the top you have also the possibility now to export this whole list into a CSV file. So if you build really large battery banks out of used cells, it is really advisable to export this from the website into a CSV file and then work with these spreadsheets then. Okay, let's quickly do another time lapse and I'll try to find all these battery cells as per this suggestion here of this website. Alright, we've got them all ticked off of the list and we've got them all stacked up, and I just realized that we have a difference between number 4 and number 3. There's one less and here's one too much. Well, and now, like in the US, I need to count again. Okay, I found it. I found the cell. So we have now exactly 8 battery cells for each pack, for each parallel pack. And as always, the recount did not change the result, right? Okay guys, I think we've got a pretty good result now with our battery cells, with our packing here of these 56 used laptop battery cells. And remember, we've got only 1 milliampere hour difference between these battery packs now. I mean, at the end, I don't expect to these measurements I did here on these capacity measurements focus. These capacity measurements, I don't expect them to be 100% accurate anyway. This is only one measurement I did for a used cell. You probably need to do 3 or 4, maybe 5 even capacity tests, and then you've got an average for each cell which you can work with, but I've done only one, so I don't know if this capacity decreases or increases with the next couple of recharges, so we will find out. Okay, so far this third tutorial here, workshop to build a 24 volt lithium ion battery to replace my 24 volt lead acid battery in the solar gate. And I think in one of the next workshops we start actually building this pack. So far this was just to show you how to balance and repack these masses of single battery cells you may have from laptops or electric bikes or scooters or wherever you get them from. Either you do it manually and have to swap over capacities so to match your battery packs, or you use the rePackr website, which I think was a little bit easier to do. And also a lot quicker, let me tell you that. This whole thing, this took me now less than half an hour, while the other one, the manual procedure, was like 1.5 to 2 hours. But I've shown you both ways now, so you can decide which one is working better for you, and it's probably good to see both sides as well, so you understand why you need to do that and how you do it. Yeah, please let me know if you have any further questions in how you do that. And I would be also interested, have you done this before with your used battery cells and have repacked them into other battery packs now? What was your project you were working on? What have you done in the past to do that? And did you use the website to repack them, or did you use the manual method to do that? Yeah, so leave all your comments and stories down below. I'm really keen to read them all, of course. And by the way, you are so crazy. We've got over 700 subscribers now here on the channel. I mean, this is taking off. I was never expecting so much feedback and interest in this whole stuff here, but I mean, you keep me going, definitely. Thank you so much for all your subscriptions, all your comments, all your information. Some people have sent me emails and we are in contact now. So as long as I've got time, I'm happy to do that, but there might be a time where email responses will be delayed heavily because I will be so busy here in the workshop then. Once all the equipment turned up, so it trickles in slowly, but I'm still waiting for the capacity tester. Okay guys, again, thank you so much for watching. Thanks for all your support here, and yeah, well, we shall see us again in the next video then, very soon, right? Okay, thanks again guys, see ya, bye bye. I hope this paint comes off here. I left it on there too long. The red pen is sticking on the table now. Probably forever. That's not good. Ah, come on.